We're going to look at the same example now to guide us through our last data representation, which is Venn diagrams. And we worked a little bit with Venn diagrams with sets. So here's what we're going to do, is we are going to contain our Venn diagram in a rectangle with two circles in it. One of these circles is going to represent Florida. One is going to represent New York. And we're just going to start with what we know we can start with. 100 people, 45 to New York, 56 to Florida, 18 have been to both. Hey, that's the overlap. Great. So now I'm going to work backwards from there. And I say, okay, well, I know that 56 have been to Florida. So this 18 has to add with whatever number goes in here to get me the 56. So I'm just going to do some subtraction, and I should get 38. And that gets me 56 to Florida. Okay, well, 45 have been to New York, so I know whatever number comes here has to add with the 18 to get me to 45. We should get 27. And so now, you might be thinking, okay, we have all our numbers, so where does this 100 people come in? Well, we have 3 numbers here, but I need a number outside to represent people who have not been to Florida and have not been to New York. And that, all 4 of these numbers need to add to 100. So really I'm just going to do 100 minus 38 minus 18 minus 27. And that's going to get me 17. And so what I want you to notice is comparing this Venn diagram to this two-way table is we just place these numbers into the Venn diagram. So these are all the joint frequencies of the two-way tables. So let's do some probability examples. Let's start with the probability that someone has been to Florida. Well, the entire Florida bubble is right here. So I can just add the 38 plus the 18. I know 100 people were surveyed, and I can also just look at the information. That's 56. I'm going to make it a percent because it's already out of 100, and that's just easier. Ooh, probability Florida complement, meaning those who have not been to Florida. So anyone who has not been to Florida cannot, it's basically any number outside of the Florida bubble. So that's the 27 and the 17. And so we're going to get 44 out of 100. The probability that you've been to Florida and New York, well, that's just going to be our section of overlap right here. And so that's going to give us an 18 out of 100. Or the probability that you are Florida or New York, so that you've been to either one. I don't know if you guys remember, but when we talked about sets and it talked about or, talked about everything in the 2 circles. So I'm just going to add the 38 plus the 18 plus the 27 out of the total 100. So I get that 83%. Okay, let's do some conditional probability. Let's look at the probability that you've been to Florida given that you've been to New York. Well, remember, this is our condition now, so this becomes the total that I'm looking at. So I'm going to have to add that 18 and that 27 to get the total. How many of those have been to Florida? Well, that would be 18. So help me, if someone cancels that, I will flip my chair backward. That is bad math to the extreme. You have to add the denominator together first, people. I'm not going to make that 1 a percent because I can't do it in my head, but I can reduce that in my head. 2/5. Okay, let's switch it this time. What is the probability that you have not been to New York, given that you've gone to Florida? Remember, here's our Florida bubble. So I know the total is going to be that 38 plus the 18. Well, those who haven't been to New York would be anyone who's not in the New York bubble. So that'd be just that 38 right there. And I just cancel. I said cancel. I meant simplify and reduce. Oh, I just talked about it. That's why. Okay, I'm trying to do this in my head. 56. And then I can reduce that. Ugh, I don't feel like reducing it right now. Anyway, that should be enough information to get you through Venn diagrams.